Today we are talking about quadratic inequalities. And so the stuff that we learned the previous day, 4.3, I guess 2 days, we're going to utilize that to talk about quadratic inequalities. And so if you remember what the graph of a quadratic function looks like, it's a parabola, right? You can have one that opens up, you can have one that opens down, so one is over here. We'll talk about that one later. But remember that when we're talking about a function, and we say, well, f of x, remember that is the y value, right? That's the vertical value of that function. It's the output. You put in an x, you get a y. You put in a horizontal value, you get a vertical value. That's basically how the functions work, right? And so if we were given this graph, and let's say we're going to call this function f. Tried to write it using a computer program, but it didn't work very good. We're going to call that f of x. We want to know at what intervals is that function greater than 0. So what we're asking is, for what x values is y greater than 0? That's what we're trying to find. So if y is greater than 0, are we above or below the x-axis? We're going to be above, right? If it was below, it'd be negative. It'd be less than 0. And so if you want to know where is this graph above the x-axis, which region are you going to be looking at? It's going to be here, right? And here. And so what do you think those intervals would be? Any idea?
The number on the y.
But okay, so the ones in the y, that just means that it's above the x-axis, it's greater than 0. But we want to know what x values is that happening at. So it'd be from negative infinity to 0, right? We wouldn't include the 0 because it's equal to 0 at 0. And then from what else? Where else is it above the little x-axis? This is just 1, 2, 3, 4. In case you can't see, I know it's a little small, but projector. What other interval?
3 to 4.
Close. 3 to 4 is right here, right? And my curve is still below.
Oh.
Where does it go above? At 4, it starts, well, after 4. At 4 is at 0, but after 4, it starts going above. So that second interval is going to be from 4 to positive, or infinity. Any questions on that? What if we wanted to make it, we wanted to find the intervals where f of x is greater than or equal to 0? What would be my intervals for that? It's the same as here, right? But we just included the equal to. So it's going to, yeah, you know it?
So bracket?
No.
No, I don't know.
Hey, I mean, I think you had the right idea. You just maybe said it wrong. But we'd have negative infinity to 0 still, but we're going to include the 0, right? So we're going to put a bracket. And it's going to be from 4 to infinity, but we're going to include the 4. So we're going to put a bracket on. Any questions on that? Good there. What if we want to know where f of x is less than 0? That's where it's below the x-axis. And so for what intervals is it below the x-axis? It's above it here, from negative infinity to 0. It's above it here from 4 to infinity. But between 0 and 4, the curve goes below. And so it's going to be from 0 to 4. Since it's not equal, we're going to put parentheses. So from 0 to 4 is below the x-axis, it's less than 0. Any questions on that? And lastly, what if we want to know where f of x is less than or equal to 0?
It'll be the same thing though, right?
Same thing with brackets, yep, because we need to include the 0, we need to include the 4, because that's where it's equal to 0. Any questions on that? I'll give you one to try on you. So here, we're going to call this one g of x. Want to know where is g of x greater than 0? Where g of x is greater than or equal to 0? Where g of x is less than 0? And where g of x is less than or equal to 0? Notice that it's a different type of parabola, right? The other one opened up, this one opened down. Give it a shot. I think. All right, so for this one, if we want to know where it's greater than 0, it's just where it's above the x-axis. And so you can see that it starts going above the x-axis after 2 and stops being above the x-axis a little bit before 4. So this is going to be from 2 to 4, not including the 2 to 4. Any questions on that one? You want to know where it's greater than or equal? Same interval, but you just include the 2. So that's where it's equal to 0. Now, if we want to know where it's less than, that's going to be where it's below the x-axis. And so you see it's going to be 2 different intervals, right? It's going to be everything to the left up to 2, and from 4 on and on and on. So this is going to be from negative infinity to 2 union. Let me run out of room here. 4 to infinity. And then if we want to include 0, g of x is less than or equal to 0. Same thing, except on those values, we're going to put a bracket to include them. That's all it is. So notice that we were talking about where it's greater than or equal to 0, or less than or equal to less than 0. That's why we're always talking in x values. A common mistake people make is they start talking about y values. But the only thing we're worried about with the y values is it above or below the x-axis? That's all we really care about. Any questions on that? So if we're given a graph, we can visually pick it out. But what if we're just given an equation? So what if they ask us the problem right here? X squared minus 4x minus 12 is less than or equal to 0. We could graph it, graph the whole thing, find the vertex, find the intercepts, which way does it open, boom, 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 and then do it. That's one way we can do it. Another way we can do it is similar, but we don't have to find all that information. All we need to do is find out where it's equal to 0 and which way does it open. If we know which way it opens and where it's equal to 0, we can draw like a crude graph of it and determine the inequality solution from there. So these are the steps. I'm not a big fan of writing things in steps, but we'll follow this. So the first thing, you want to move all terms to one side of the inequality so that the other side is 0. Just like when we were solving a quadratic equation, you want to move everything to one side, unless you're doing a square root method. But normally you want to move everything to one side, factor it, and go from there. Same idea here. We want to get it in reference to 0 so that way we can use those intercepts. Next thing we want to do, change our inequality to an equation. I want to know, where does it equal 0? I want to know when ax squared plus bx plus c is equal to 0. That's going to give me my intercepts. That's going to be where it's changing from either being above or below the x-axis, right? We're going to solve that quadratic equation. That's going to tell us the x-intercepts. Next thing I'm going to do, take that inequality that you had set with one side being 0, and you want to decide if a is greater than 0, and it opens up. If a is less than 0, and it opens down. Okay. And then we're going to draw a quick sketch from that. And that is how we're going to solve. Any questions on that? Let's do an example. So we got x squared minus 4x minus 12 is less than or equal to 0. It's already got everything moved to one side, so one side is 0, so we're good to go there. But if the 12 was on the other side, subtract 12 from both sides. Once we have that, we're going to set it up as an equation. I want to find my x-intercepts. And so to find my x-intercepts, I'm going to say, well, x squared minus 4x minus 12 is equal to 0. And I'm going to solve that. That's going to give me my x-intercepts. So if we try to factor that, let's do it. AC is equal to negative 12. D is equal to negative 4. One thing is to multiply, give me negative 12. Add to give me negative 4. I think 6 and 2 are my candidates. Let's figure out which one needs to be negative, though. Negative 6. And so this is going to factor be x minus 6 times x plus 2. Is equal to 0. And so that means that x is equal to 6 or negative 2. Any questions on that? All right, so that tells us where our graph is going to intersect the x-axis. So now we can start drawing. So let's draw. You don't have to label it every time. I'm going to label it this time. It's the x-axis. Right? We don't care about the y-axis whatsoever. You think about those two examples we did. I cared about the y values, but that can be determined based on if it's above or below the x-axis. So I don't really need the y-axis whatsoever. We know it intersects it twice at 6 and negative 2, but let's write it in the correct order. Put negative 2 right here. Put 6 right here. Doesn't have to be beautiful, doesn't have to be perfect, just has to be readable. Which way does this open up? Which way does x squared minus 4x minus 12 open? Up or down? What's the a value? Just a 1, right? Because it's x squared, so that's 1x squared. So if a is 1, it's positive, and it's going to open up. Remember, if it's negative, it's going to open down. If it's positive, it's going to open up. Yep, good job. I both got it. So that means I know what my graph's going to look like. It intersects here and here, and it opens up, so it should look like that. So let's draw it. Any questions on that? I don't care how far below it goes down, below the x-axis. I don't care how fast it grows. I just know this is basically my shape, right? It opens upwards and intersects at negative 2 and 6. Any questions on the drawing? Nope. All right, so now let's revisit what we were trying to find. We were trying to find where it's less than or equal to 0. Where is that graph less than or equal to 0. Where is that graph? On the x-axis or below the x-axis? Well, it's above the x-axis here and here, but in between is below. So that means that it is below or equal to on that interval right there. I don't know if it didn't really show up too well for you, but maybe it'll be yellow. Yeah. And so that means that the interval in which it is less than or equal to 0 on the x-axis or below the x-axis is from -2 to 6. But since we want to know where it's equal as well, include those in here. And that's going to be our solution. So if you pick any number between -2 and 6, including -2 or 6, x squared minus 4x minus 12 is going to be less than or equal to 0. Any questions on that? No, we're good. Give y'all one to try on your own. Oh, where did I put it? Oh, there it is. You got x squared plus 2x plus 1. You want to know where it's greater than 0. So, same thing. It's already set up. We already have one side is 0. So, next thing we're going to do, write it as an equation. Jeez. One second. There we go. So, we're write as x squared plus 2x plus 1 is equal to 0. Let's try to solve for x. That's going to tell us our x-intercepts. So, this is going to be x plus 1 times x plus 1 equals 0. Is that right? Good. And so that means that x plus 1 is equal to 0. If x equals -1. That's interesting, right? That means that we only have one x-intercept. It's only one place where it intersects the x-axis. Which way does this graph open up? It opens up, yep. Because a is equal to 1 here, so that's positive, so it's going to open up, so we know it's shaped like that. And so if we want to graph this, just a crude graph like we did before, it only intersects the x-axis at -1, and it opens up. That means we know that that is the lowest point right there, and it just grows up from there. So if we want to know where it's greater than 0, where is it above the x-axis? Where is that going to be? Close. So that gives, that's this right here, right? That's -1 to infinity. Would you include -1? No, because it's equal to 0 at -1, right? But you also have this area here, where it's above the x-axis. So we also need to include that. So we'd also need to include -infinity to negative. We're just taking away -1, because -1 is where it's equal to 0. If, well, any questions on that? If this was equal to, greater than or equal to, then -infinity to positive infinity. Because it would include the 0, and then -1 is equal to 0, so it would be for all real. But for this one, it only has a single x-intercept. That's your vertex. And so it's above it all the time. If you ask if this was less than 0, what do you think the answer would be? If you said, where is x squared plus 2x plus 1 less than 0? Where is it below the x-axis? Is it ever below the x-axis? No. So this would be no solution. There are no numbers such that that is below the x-axis. There's a few things that can happen. That's kind of a good example of all the different things that can happen. I think there's one more situation that can arise. Any questions on that one? Number 2. Oh, I mixed up number 3 and number 2. I'm assuming I threw them in order for a reason. Yeah, negative 3x squared minus 9x is less than or equal to 0. We're going to start, move everything over. So one side 0, that's already done for us. So we'll start with negative 3x squared minus 9x is equal to 0. And to solve that one, we're not going to use the AC method. We're going to try to factor out common terms first. So both of them have a 3 and an x, and we could be a little bit more and say it has a negative 3 and an x. And so we'll be left with x plus 3. And that's equal to 0. So by, applying the 0 product property here, we say, well, negative 3x is equal to 0, or x plus 3 is equal to 0, which this one's going to result in x is equal to 0. This one results in x equal to negative 3. So we do have 2 x-intercepts. So that means the vertex is not on the axis. So let's mark those out. Remember, you want to do them in order. So negative 3 is less than 0. So we're going to put negative 3 here. We're going to put 0. Be careful with that. That's a common thing people mess up, especially if you solve it like I did, where 0 is first and then negative 3. So make sure you write it. Now, which way does this one open? It's going to open down because a is equal to negative 3, and that's less than 0. That means, sorry. So that means that our parabola is going to open like this. Well, that was a really bad draw. We'll try it again. There we go. And so we want to know where it's less than or equal to 0. That's going to be where it's below the x-axis. So it's going to be here and here. So it's going to be these regions there on the outside. And so the answer to that is going to be, oh, they're still using a paintbrush. From negative infinity to negative 3, we're going to include the negative 3 because it's equal to 0. Union 0 to infinity. And we're going to include the 0 because it is where it's equal to 0 as well. Any questions on that? Nope. Interesting thing about these problems, and I usually show it, but it's not something that I'm going to make a big emphasis about. But if you don't like dealing with the negative a term, this is still an inequality, and we can still treat it as such. We can multiply both sides of this by a negative 1. And then it's going to make it 3x squared plus 9x. The only thing is that now it's going to be greater than or equal to 0. Remember, it negates the relationship of the inequality. It changes it. So you could do that for these problems as well. If you solve that one, you're going to get the same answers because it's going to flip the parabola, but it's still going to intersect at negative 3 and 0. So that is one way that people learn to do it. I don't know. Whatever works for you. I'd rather just leave it as they give it to me because it's one less step, and it's one less step I can mess up. So that's kind of how I act about it. But whatever makes more sense for you. Any questions on that? What is this one? Oh, yeah. Oh, I'm trying to scroll there. All right, so you have a couple options here. You can move the 2x to the right, or you can move the x and the 10 to the left. I like to keep my values positive, so I'm going to move the x and the 10. So we're going to have 2x squared minus x is less than 10, and then let's subtract the 10 from both sides, and we'll have 2x squared minus x minus 10 is less than 0. So this is where we want to start. It's equivalent to what they gave us before. It's equivalent to their relationship, and so this is where we're going to start at. So first thing we're going to do, set it equal to 0 now. And let's see if we can factor that. So AC is negative 20, and Bravo is negative 1. And so we want things that multiply to be negative 20, had to be negative 1, 5 and 4 are my guesses, and negative 5. And so since the A value is not 1 here, we are going to have to, do the rest of this. So we're going to write it as 2x squared minus 5x plus 4x minus 10. Yeah, it's equal to 0. I kind of run out of anything, but yeah. And then we're going to factor out what we can from the 2x squared and the 5x. And that's just going to be x. So we're going to have 2x minus 5. I want to factor stuff out of the 4x minus 10 to get 2x minus 5. So I'm going to need to factor out a positive 2. That's going to leave me with 2x minus 5. And that's equal to 0. Now they both have a 2x minus 5. Pull that out. And let me fix up that x. We're going to be left with x plus 2. And so now we can apply the zero product property and say, well, 2x minus 5 equals 0, and x plus 2 is equal to 0, which is going to result in x is equal to 5 halves and negative 2. So those are my intercepts. I have my answer, but they're important. So now we need to draw our stuff. I'm going to come over here to the left. Anybody was still copying this down? No, we're good. And I'm going to draw my graph. And remember, negative 2 on the left here. 5 halves is here. Doesn't matter that we have a fraction, just do it the same way. Which way does this open? Up or down? Opens up. This is a 2x squared. A is 2, that's positive. If you had done it the other way, where you move the 2x at the beginning and you had a negative, it would open down, but you'll still get the same answer again. And so we want to know what? I don't even remember. We're basing it off of this. Oh, nope, not that. This. Where one side's 0. We want to know where it's less than 0, right? So where's it below the x-axis? Right there, it looks like. Let's mark it. And so we're going to have our solution set is going to be from negative 2 to 5 halves. Do we include the negative 2 in the 5 halves? No, because it's not equal to in our inequality. And so that's going to be our solution there.